All right, so this is the Northern Hemisphere 2024. I've just grabbed a couple of questions that I want to go through. So below is a time series plot of the high tides and low tides for Sydney over the 60 days. So we can see that there. Now it says complete the sentence below by entering. Oh, actually, I should have kept reading up here. It says the thick line, so there's a thick line there in the thing, and it says is a result of smoothing using a moving median. All right, so they've done median smoothing, and we know we lose values when we do the median smoothing. We lose some at the start and some at the end, and it depends on what type of and what number of median smoothing we're doing. So here when it says down the bottom, it says complete the sentence below by entering the number in the box. So both the HHT, the high tide and low tide, have been used, been smoothed using what number median smoothing. So what you want to do here is you want to look at, you can see this is where the smooth line starts. So if you look at it there, you've actually got 1, 2, 3, 4, 5, 6. You've got 7 values before your first smooth value. So remember when we do the median, we're finding the middle value. So if you've got 7, then you'd have your median, and then you would have your 7 after it because you're trying to find the middle value. Well, then you can see that you must have 15. So it's 15. So when you have 15, you lose the first 7, and you'll also see that you lose the last 7. All right, so what I'm going to do here is, I think this is sort of a new question style. So I wanted to just write down a little bit of a summary. So we had so if we have mean and median smoothing, so if we have mean and median smoothing with odd numbers, so say we had 3 median smoothing, we would lose the first and the last value. So you pretty much lose 1 each end. Okay, so if you have 5, you lose 2 at the start and 2 at the end. And then so on. So I'm just so if you write that, it's going to be the same, but 7 we lose 3, 9 we lose 4, 11 we lose 5, 13 6, and 15 7. So I just feel like they're probably going to bring this up because they're it's a new sort of thing, and making sure. If we're doing even smoothing, now when we have even number smoothing, remember it's generally with the mean, because we also need to have centering. So they have to say that, and they will put the centering. They'll say there's centering with it. So with the even numbers and the centering, if you have 2 mean with centering, you lose 1 at each end. I'll just write each end. And then if you have 4, you lose 2, 6, you lose 3, 8, you lose 4, 10, you lose 5 each end, and 12. So just in case they decide to do that one, a graph, they might have the mean or something, they'll say how many you're going to lose. So you've got that there. All right, so moving on. This next question 6. So I've had a lot of questions about the normal distribution. So I just want to go through this one. So weights of the fish production are approximately normally distributed. So as soon as you see that, you should be just draw your bell, because that's what that means. And then often they come up with some information. So they said the mean was 126.4, and a standard deviation of 2.4. So, you can go up 1 standard deviation, 2 or 3, or you can go down 1 2, or 3. Okay. Yeah, so then it says, it tells you a number. You've got, this is how many we have in total. And it said, using the 68, 95, 99 rule, which you can only use when you have approximately symmetric, it says how many, the number, so you want a number of cans that weighed between 121.6 and 128. So those two numbers are going to be something around the mean. They're going to be so many standard deviations around the mean. So if you have a look, if you go down -2 standard deviations, you'll get down to 121.6. So what I'm saying, that number was the mean minus 2 of the standard deviations, which was this 2.4. Okay, so that's 1.26, and then it also said between 128, which is actually just one standard deviation up. So that's 128. So really, we want to know how many of these fish, or weights of the cans of fish, weigh between here. So when you go down 2, you know that this pocket here is 2.5%. When you have 1, you know that pocket is 16%. So here in the middle is 100 minus those 2 pockets, which would be 18.5. Okay, so in here is 81.5% of all the cans of fish. So, but because we want number, so we're going to say 81.5% of the 13,600. So when you write the decimal as a fraction, and of means times, so you can always just change that to that, and then you end up with 11,084. So we've got that. So they seem to be asking a lot of little mix match of standard deviation and mean there. All right, with this next one, it says a class investigation considered 20 countries and any association between birth rate per 1,000 people and life expectancy. So students were given the following summary table. And okay, so we can see all of that. And then scatter plots A to E shows the attempts of 5 students to fit and calculate the least squares line. Which of these graphs is complete? So that line is your y equals a plus y, equals a plus bx. So we need to get that equation. So first of all, I'm going to look here. They all say birth rate is it's not drawing. They're saying birth rate is the RV. So I just want to put up there RV, and life expectancy is the EV. So we would just write above it so that you don't mess up what stat that actually is. So because that's an EV, so really this RV is the Y value. So when they say mean of Y, we've got that, and we've got the standard deviation of Y there, and this one's the mean of X and the standard deviation of X. Now we need that least squares regression line. So we want to find out what this rule is so that we can see which one's correct on the graph. So we'll go to those formulas. So remember, B equals R times SY over SX. So you've got those values there. So just make sure you've picked the right way. So they've put the Y first in the table. So we do that and we get -2. So this is the B value. And then I do the other formula for the Y value. And so I plug those numbers in. So it was 31.5 minus a minus 2.155. times 61.7. So this ends up with 164.46. All right, so now what I actually have, I'm just going to move it down here a bit. I can actually write the equation that we should, the kids, should be drawing on it. So they have birth rate equals, this is the A value, and this was the B value, and times life expectancy. So we've been obviously practicing. If you had to draw this on the graph yourself, say they gave you the scatter plot and you had to draw it, remember I said you need to plug this value into your equation and also that value. And if you look at all our options here, they all have the same scale there. So we should be able to sub that in and get the right one. So if we sub in that the x is 59 into this formula, it would be 164.46 minus 2.155 times 59. If you do that, you end up with 37.32. And then if you sub the end one value in, x should equal, if it was 65, so you do equals 1646 minus 2.155 times 65, and we get a value. So we should be looking for that. So when we look along, so when it was 59, I should see it being 37.32 on the birth rate. So 59, what am I saying? 37.32. So that one looks like it's close to 37. You can see this one is under, so I'm getting rid of that. This one is at, well, they're jumping up in 4. No, what are they jumping up in? Yeah, they're jumping up in 2s. This one's scale is, look at the scale on this thing. It's going around the wrong way. So that one's completely wrong. The numbers aren't even working. This one, so you got 20. This one's on 38. So I could get rid of that. And this one's under. So I've nearly got rid of them just by doing one. But let's double check. The first, when it's 65, it should be 24. So hopefully when I go down here, I see that this value is close to the 24, which it is. So there's the answer. So that one's correct. All right. Okay, so with this one, the sales revenue in dollars from sales of chocolate eggs is seasonal. So you know you've got some seasonality. So to correct for this sales revenue for May for seasonality, when they say that, that means you are deseasonalizing the data. So if you they're deseasonalizing, and if you wrote that formula, that's what deseasonalize is, the formula. So to correct that to deseasonalize, the actual sales revenue to the nearest cent is decreased by 17%. So when they deseasonalize the value, it went down by 17% in May. So the seasonal index for that month is. So what you want to do here, we talked about this in class, is they want the seasonal index. So the question here is that this seasonal index. So if I rearrange this formula, and I think you have got these in your notes, but if I wrote seasonal index would actually be the actual divided by the deseasonalized value. Yeah, so that would give you the seasonal index. So what I'm going to do is I'm going to make up a value, an actual. So I make up an actual, and I said to my class, just make up an actual of 100, as if it was like 100%. And then if the deseasonal, it said when you deseasonalized, it said it went down by 17%. So the deseasonalized value must have equaled 100 minus the 17, which would equal 83. So if I go to find the seasonal index, all I have to do